Today we are on unit 4.5. Okay, and 4.5 we are still working on parabolas. Parabolas in descriptive form. More parabolas in descriptive form. Okay. So we are doing more parabolas in descriptive form. Okay. So I am going to ask you to graph, label line of symmetry and vertex. Okay, so we're going to graph, label line of symmetry, and the vertex. So for example number 1, I would like you to graph, label line of symmetry and vertex in y equals 2 times x plus 1 quantity squared minus 4. Graph, label line of symmetry and the vertex. So automatically you should be able to tell a couple things here. What direction is this going to open? This is opening up. And what is its width? Is it going to be fat, skinny, or normal? This will be skinny because it's a whole number. Okay, whole numbers except for 1 are skinny. What can I tell about its shape? What is its line of symmetry? Try again. Line of symmetry is x equals -1. Have to say it as an equation. Okay, I want you to get in the habit of saying it as an equation. And what is the vertex? -1, -4. So change, keep. Change and keep. Okay, if I make my sketch, your line of symmetry is at x equals -1. Label it, even if you put the little dash marks. Okay, I still want x equals -1 labeled. And then your vertex is -1, -4. Label it, please. And then we said that this is going which direction? Up, and it is skinny. Okay, it is up, and it is skinny. Okay, now, would you say that this has a minimum or a maximum? This has a minimum. It is a low point. Okay, that is its minimum. Okay, let's try another one. I would like you to do the same thing. Graph, label line of symmetry and vertex for y equals -1/4 times x minus 3 quantity squared. Y equals -1/4 times x minus 3 quantity squared. Bless you. So, what do you know about the shape of this parabola? Is it going to be facing up or down? That is facing down, and what's the width? Fat, skinny, or normal? It is fat because fractions are fat. Okay, what do you know about its line of symmetry?
It's x.
Thank you. Line of symmetry is x equals +3. How about the vertex? Something missing, right? What can I add in at the end? A +0, so that means it's vertex at +3, 0. You can sketch this. So your line of symmetry will be at +3, so x equals 3. Label it, please. Vertex is over 3, up 0. 3, 0. And which direction is this going? Down, and it is fat. Okay, so a fat downward facing parabola. Now, does this have a minimum or a maximum?
Maximum.
This has a maximum. It has a high point. Okay? Maximum, because it has a high point. Okay, so just to let me see. Now, next thing I want to do with these parabolas is I would like to know something about domain and range. Okay? I know that you have seen those terms before. Okay? You might not remember them, though. Does anyone remember what is the domain? Anyone remember? Domain and range. Okay, Domain are possible x values. Okay? So possible x values. Okay? What is the domain of this parabola? What are the possible x values of this first parabola? Do you have any idea? What are the possible x values? Remember, so what are its constraints? Does it have like bars that it has to stay in between? No. Will it eventually get, way out to here? I mean, it's growing not at a really high rate, but what are the possible x values here? Does it have any constraints? No. Okay. Possible x values. The domain for all parabolas. Okay. For any parabola. The domain for any parabola is all real numbers. Okay. All we do is write double R like that. That means all reals. Okay. So that means that any x value would be on this graph. Okay. If I want to figure out, where x is 5 over here, eventually this graph is going to get there and it would cross 5, right? Okay, we'll have an x value of 5. So all reals. For all parabolas, your answer is going to be all reals. So if I went back up here and I wrote my domain, okay, domain is all real numbers. Okay, domain would be all real numbers. The range, if the domain is the possible x values, what do you think the range is? Possible y values, exactly. Possible y values. Now, for all parabolas, all real numbers is your domain, okay? The range, is it possible to get to get all y values? Do you think this is going to be all y values? No, because it has a minimum, correct? So the range, what is the range of this parabola? What are the possible y values? Not anything greater than -1, -4, because we're only looking at the y values. So y values are all going to be above -4, correct? Anything above it. So the range here would be y greater than or equal to -4. Okay, so we're labeling what are the possible y values that could be in here. Okay, so what are the possible y values if I wrote out every single point, basically? Okay, for domain, you could get any x value because it keeps growing and growing and growing. Y values, it will never get below -4. Okay, now let's try labeling the domain and range here. What is the range, or excuse me, the domain for this parabola? All real numbers, okay? Always. For every parabola, your domain is always all real numbers because any x value is possible, excuse me. How about your range? If this has a maximum, does that mean the y values are going to be greater than or less than? Less than. So your range would be y less than or equal to, what is the highest your y value will get? 0. That's how we do domain and range. Okay, so you're doing domain and range. That's going to be added on to your descriptive formula. Okay, so it's just something that you kind of have to think about. Okay, sometimes we will not ask you for the graph, but we will still ask you for domain or range. I would encourage you to draw just a quick sketch because it's easier for people to understand it when you see it. Okay, so don't always just look at your numbers. Okay, make sure that you're actually drawing a sketch and it helps a bit. Okay, so let's go back, and for number 3, okay, we're going to say, looking back at number 1. Looking at number 1, I would like you to write the equation. Looking back at number 1, write the equation given a shift or move, okay, given a shift of 4 to the right and up 3. So if I went back to number 1, and I say I want you to write the new equation. Okay? Write the new equation. Okay, so we want to write the new equation if this parabola was shifted. Okay? So let's just do a real basic sketch of number 1. Okay, I'm just going to read you number 1. We know that it had an x-intercept at -1, or excuse me, a line of symmetry at -1, and its vertex was -1, -4. Okay, it had a vertex at -1, -4. And it was still skinny. Okay, it was skinny. Now, if I move this entire equation, if I move this entire shape 4 to the right and up 3, what is the most important thing that I'm moving here? Well, I'm moving the whole parabola, but what does your equation come from? What does your equation tell you a lot about? Tells you about the line of symmetry. What else does it tell you? The vertex. Okay? So all you really need to do in these moves and shifts is look at what it does to the vertex. Okay? So we're going to figure out, where does this move the vertex? So if I move right 4, so that means I would go over 1, 2, 3, 4, and up 1, 2, 3. What is my new vertex going to be? If I move right 4 and up 3, my new vertex is at what? 3, -1. 3, -1. Now, do you think it's going to change anything about the shape? No, it's still going to be skinny, okay? And it's going to be going up. So the only thing that you need to be concerned with is the new vertex, okay? Now, if I want to write my equation, remember, I always have a y equals. I have something inside the parentheses with a square. You know, you have an x, something inside of the square. Does what was in front change? No. So what was in front of my original equation? A 2. A 2 stays exactly the same. Okay. What do you know about what's inside the parentheses? This is your vertex, right? And remember, I change it and keep the sign. Change the sign, keep the sign. So if I change the direction of my x coordinate, what would that be? -3. And if I keep the y coordinate, -1. That's your answer. Okay? So if I asked you to rewrite this as a shifted equation, okay, just shifting equations, this is your answer. So y equals 2 times x minus 3 squared minus 1. Okay, let's do one more. Okay, for number 4, where did I get the 2 from? The 2 came from the original equation. Okay, it came from that original equation. Okay, so if I'm going to say given, you are given the equation y minus 7 equals x plus 2 quantity squared. Y minus 7 equals x plus 2 quantity squared. I want you to write a new equation. Write a new equation if shifted 1 left and down 2. Write a new equation. Shifted 1 left and down 2. So, first off, what's wrong with this equation? It's not y by itself. So how could I get y by itself? Add 7. So this is the same equation as y equals, now where should the 7 go? At the end. So y equals x plus 2 quantity squared plus 7. Okay, do we all agree that's my new equation? Okay. What does this tell you? That my line of symmetry is where? Line of symmetry is at x equals -2. And where is my vertex? -2, 7. So let's just draw that. Okay, so draw my vertex.